Let's take the derivative of this nasty function. Take it step by step. The first thing to recognize is that it is a quotient of fractions, so you need the quotient rule. Low d high minus high d low over the square of what's below. Low is easy. The hard part is d high. It might not be a bad idea to initially just write that as ddx of, well, just to save time, I'll use an arrow there. Low d high minus high. There it is. I'll go ahead and write it out this time. D low, the derivative of ln of x, that's easy. That's 1 over x. Over the square of what's below, over ln of x quantity squared. So the main part of the work that you need to do is taking d high, the derivative of the high function. It is the product of three functions, x squared, e to the negative 3x, and inverse tangent of secant of x. Is there a product rule for the product of three functions? Yes, there is, but you don't need to know it. You can break it down into the product of two functions like that, x squared e to the negative 3x times inverse tangent of secant of x. Although with the derivative of that first part, you need the product rule as well. So you do need to use the product rule more than once. Let's do that now. So we get ln of x, okay. Derivative of this, I'm thinking of it as this thing times this thing. So I think about the product rule, left d right plus right d left. Left function is x squared e to the negative 3x. D right means the derivative of the right function, for which I need the chain rule because I've got secant of x inside there instead of x. I remember the derivative of inverse tangent of x is 1 over 1 plus x squared. So I start to write that. But then the x squared has to get replaced with whatever's inside the parentheses, which is secant of x. So I could write secant squared x times the derivative of that inside function. The derivative of secant of x is secant of x times tangent of x. That's left d right. Plus, I can tell I'm going to run out of room here. That's okay if you went into the next line here as well. That's left d right plus right inverse tangent of secant of x. D left, derivative of that, which I need the product rule for. Again, use parentheses because I'm going to multiply by a sum. Left d right plus right d left in there. Left x squared. D right e to the negative 3x times negative 3. The dot is essential there, unless you put the negative 3 in front. That is a negative 3 if you can't quite tell. Left d right plus right e to the negative 3x. D left means derivative of x squared is 2x. All right, so what we got here again for the entire function on the top, there's left d right. This whole thing is d right plus right d left. That entire thing gets multiplied by ln of x. Really big parentheses here. And then, okay, minus whatever else is over here. I can simplify a little bit if I want, though don't make a mistake if you do. I canceled one x. X e to the negative 3x inverse tangent of secant of x. If you're afraid you're going to make a mistake, then don't bother canceling. This is all in the numerator of this fraction, and the denominator is ln of x quantity squared. Done. Okay, in reality, it'd be better to put this over there, but I didn't have room. Give thanks to the Lord, for he is good, and he will never make you compute this with a limit. These derivative rules are very powerful, though. We can do amazing things.